Hello, welcome back. This is episode 17. I'm going to start looking at some common patterns because that's been a common thing that people are wanting to see is what are the patterns in functional programming, which makes sense coming from object-oriented where that's such a big deal. The patterns are considerably different, but patterns obviously emerge. Today we're going to look at map, and it'll be our first little intro into functors. I'm Reed Evans. You can find me on Twitter at ReedNEvans. And so let's look and see what is map all about, because it may be more than what you think it's about. So the definition for map is given a function from A to B and a functor of A, return a functor of B. Now often, especially when you're getting into map or the first time you've seen map, this may be seen more as given a function from A to B and an array of A's, return an array of B. As it turns out, that right here is the implementation of map for arrays. But map is actually more generic than that. Map says not necessarily an array, it says given a functor. And so what is a functor, right? Well, we've already seen that array is a functor. So you can think of in this case where we're saying functor of f here, that's like saying that for any type that implements this sort of an interface is a way to look at that. And so if we were to map over an array of the numbers 1, 2, 3, and we were to supply the increment function, then we would of course get 2, 3, 4. Keep in mind our increment function just takes an integer, returns another integer. It doesn't know anything about functors or any other sort of types. It just says give me basically a number, I will return the successor of that number. And so this works because array has an implementation defined for functor, and because array can prove that that it is a functor, then it has this. Then we can call map on it. But I keep talking about functors. What are other functors? Well, as it turns out, maybe is a functor. So if we have a maybe of 1, and maybe is a functor because there's an implementation of map that satisfies this for it, we can still use the increment function. But in this case, we can use it on our maybe value. So we have a maybe of 1. If we increment over that, we get maybe just 2. And we can also do the same thing with either, because as it turns out, either is also a functor. Now the implementation, obviously, of how to map over an array versus how to map over a maybe or an either will be different, but they still must satisfy this and a couple of functor laws. One thing to note is that in this case, all three of these cases we're using this increment function, which takes an integer and returns an integer. And that's perfectly fine because in this case, we have an array of integers. We have a maybe of an integer, an either of an integer. But keep in mind what map is here. So if we try to do something like this, we try to map the increment function over an array of strings, we get this goofy thing, right? And in fact, if JavaScript was more statically typed, this would just not compile. Because basically what we're saying is map says given a function from A to B and a functor of A, return a functor of B. But what we've really done here is we're saying we've got a function from int to int and we have an array of string and we're trying to return an array of int. That doesn't match this value here. This A has to match the type of A going into this functor. This string doesn't equal this int, and that's why we get this kind of goofy thing. Now what we could do though instead is we could use the length function. Would be a valid function. So the length function is going to take a, if we were to take this, copy it down here, instead of an int, right, it takes a string. And so in this case, this all works and we get 5 and 6 as we would expect. So hopefully that'll help you give a little bit more intuition for map and what it's used for. One One way of thinking of that is it allows you to use functions that know nothing about your functor. It allows you to use functions that don't know about your functor on values contained within your functor. Or said another way, increment here knows nothing about arrays, but because of map, we're able to use it on arrays. Increment obviously knows nothing about maybe, but because we can map, because maybe is a functor, we can map and still use this increment function on values contained within the maybes. And the same obviously for either. So there you have it. This has been our first look at map and a small introduction to functors. I've been Reed Evans. Thank you.